Okay, so we're going to start our next section now, and coming right on the heels of the Pythagorean theorem, it's going to allow us to study and get some exposure to what are referred to as the special triangle in geometry and trigonometry, and these get used right on up through pre-calculus and calculus. So really, really important lesson for your long-term high school math career, even into college. Some great information that I want you to burn into your brains. So the first thing we have to realize is that when mathematicians talk about special triangles, there's two special triangles, two and only two. They are right triangles, and they're considered special because their side length proportions, which we spent so much time talking about recently in triangle similarity and everything, are determined in such a way that we can know information about all the sides of the triangle when we only know one side initially. So it's kind of a powerful tool. So the two that we have are the 45-45-90 triangle and the 30-60-90 triangle. Those triangles, those numbers refer to their angle measures. So I need you to consider a square, and let's say it's a square that has side lengths of 1. So let's consider this square here that has side lengths of 1. And of course, because it's a square, all the angles are right angles. So what I've done is I've kind of chopped this square in half. And so you're looking at this picture over here now, which of course is a triangle with 3 sides. And you can see that these 2 sides are left unchanged. They're still of 1 unit in length. So our question now is figure out how long this hypotenuse is. Well, if we put, maybe an h there for hypotenuse, we could solve for it by using our, newfound Pythagorean theorem. 1 squared plus 1 squared equals h squared, which of course is 1 plus 1, which is 2, which is h squared. So that means h equals the square root of 2. So this missing side length is the square root of 2. And what we need to recognize is that any triangle that is an isosceles right triangle, that is, the 2 legs are the same length, so it has 2 equal sides, so it's isosceles, is going to have the nature that these angles that get formed here are going to be 45-degree angles, because remember, we have the isosceles triangle theorems that says that if the 2 angles of a triangle are congruent, the sides across from them are congruent. Well, we have the converse of the isosceles triangle theorem that says if we have these 2 sides that are congruent, which we know that they are because they're both 1s, then the angles across from them must be congruent. And because these 2 angles must be congruent, they must be both 45, because they have to make up a total of 90 degrees on this side for these 2 angles, because we've got 180 total and we've got 90 here. So 90 plus these 90 is going to be 180. So the 45-45-90 triangle is really special in that we have these known side lengths to be 1, 1, and root 2. But the question is, well, what if my side lengths aren't 1? What if my side length is, I don't know, draw another fresh one over here, and let's say that this is 45 degrees, and this is a 90. So then we know that this is 45 degrees, and we know that this is 3. Well, this over here will also be 3, because the angles across them are congruent. And then the question becomes, what's this hypotenuse going to be? Well, once again, 3 squared plus 3 squared is going to be our hypotenuse squared. So 9 and 9 is 18. And our hypotenuse squared is 18. That means our hypotenuse is going to be the square root of 18, which is the square root of 9, square root of 2, which is 3 root 2. So what you have is, when these 2 sides are 3, this side is 3 root 2. And notice when these 2 sides were 1, the hypotenuse was 1 times the square root of 2. There's kind of like an implied 1 there. So that is the pattern, that our side lengths will be, the 2 legs will be equal, and the hypotenuse will be root 2 times as much as whatever the side lengths are. So you can think in the general case, if we have a 45-45-90 triangle, it's a pretty horribly drawn one, but if these are equal, whatever side length that is, S, and whatever side length this is, they'll be the same. If we have a 45 here, this will be S multiplied by root 2. So again, if you have 10 here and 10 here, this will be 10 root 2. So our 45-45-90 triangle formula is S, S, S root 2. And what that means is the 2 legs will be the same, and the hypotenuse will be root 2 times whatever the legs are. So we take our first example here. where we have a side length given to be 5, and the question is find the missing side lengths where we were given one of the two legs. So because this side is 5, we know this side must be 5. And once you know that those two guys are 5, you know the hypotenuse must be 5 root 2. So that's really becomes a trivial exercise. As soon as you recognize that you have a 45, 45, 90 triangle and you're given a leg, the other leg is going to be equal. The hypotenuse is going to be root 2 times as much. Now, we have a little more work down here in the second example where we are given the hypotenuse and we kind of got to work backwards for the legs. And the shortcut that I'm going to give you is if you're given the hypotenuse, you want to divide it by 2 and then multiply by root 2. Now, those of you who are pretty slick with that recognize that you're essentially dividing it by root 2. And you could think of, if you started with this one of the 5 root 2, if you just take that hypotenuse and you take 5 root 2 and divide it by root 2, you'd see that that's canceling that out and you're going to get to the 5 here. So that's essentially what we're going to do. We're going to take this 12 and we're going to divide it by root 2. But the quicker way to do it to ensure that you're going to have a simplified result is to divide the starting number by 2 and then multiply by root 2. So this leg over here will be 12 divided by 2, which is 6, and then we multiply it by root 2. So the two legs are going to be 6 root 2. And if you don't believe me, imagine we had this to be 6 root 2. Then, of course, we know the other leg will be 6 root 2. And the question would be, what would this be? Well, as it turns out, it better be 12. And remember, the way to get this hypotenuse is to take the leg and multiply it by root 2. So 6 root 2, which is the leg, multiply it by root 2. And of course, root 2 times root 2 is a 2, or the square root of 4, which is 2. And of course, you get 12. So remember this, when you're given the hypotenuse, all you need to do to find out what one of the legs is divide the hypotenuse by 2 and then slap a root 2 on it, multiply it by root 2. That works no matter what. Even if you're given the hypotenuse as an odd number, let's say you were given a hypotenuse of 11. Well, divide 11 by 2, which is just simply put a fraction bar, put a 2 underneath it, and then slap a root 2 on it. 11 over 2 root 2. And this, of course, would be the same, 11 over 2 root 2. Great trick. Now for our second special triangle, the 30, 60, 90 triangle, what we're going to do is start with an equilateral triangle, which you can see up here on the left side. We're going to assume that this is equilateral. I'll go ahead and put some tick marks on it to show it's equilateral. And we know that if it's equilateral, it's also going to be equiangular, which means all the angles are going to be 60 degrees. So you got a 60 there, a 60 there, and a 60 up here. Now, imagine taking that triangle and chopping it right down the center here, dropping a perpendicular to get that. And what you're seeing is this right side of this triangle, this guy. I've just kind of put him over here. So again, if we had started, this time I'm going to start rather than side lengths of 1, like we did with my square in the last example, I'm going to start with side lengths of 2, and it's going to make sense in a minute. So I know that this side right here corresponds to this side right here. We're just taking this triangle and just showing the right half of it over here. So I know that this hypotenuse is 2. I also know that when I drop that perpendicular down and in an isosceles triangle situation, you could think of this side being equal to that side, and that of course means this triangle we just think of as isosceles. That's going to bisect this angle up here by creating two congruent triangles. These two triangles are going to be congruent. So I now know that this angle up here is 30 degrees. This one's down here is still 60, and of course we made a right angle. So what we've done is created our 30, 60, 90 triangle. The other thing I know is that because this triangle over here and this triangle over here are congruent to one another, this side must be congruent to that side. And if they're congruent to each other and the total length is 2, they must each be 1. So that's what's so beneficial about starting with side lengths of 2, is because when I chop it in half, it gives me a side length of 1. Now, what we're missing is this side here, which is one of the legs of the right triangle, and it's what I would consider the long leg, and we're going to figure out how long that guy is. So let's do Pythag to figure that out. 1 squared plus our question mark squared has to equal 2 squared. Well, 1 plus question mark squared is equal to 4, which means question mark squared has to be equal to 3. Subtracted 1 from both sides, which means our question mark is the square root of 3. So I can put a square root of 3 on this side, and I now have a template for the formula for the 30, 60, 90 triangle. 1, root 3, and 2. Going from the smallest side, 1, the longer of the two legs, root 3, and the hypotenuse, 2. And the beauty of this is, regardless of what this side length is down here, because you could think about a triangle when you have a 30, 60, 90, when you have a longer side down here, let's say it's 4. What you can do is follow this pattern, that the long leg, this guy here, will be root 3 times as much as the short leg. So this would be 4 times root 3. So I took a root 3 and multiplied it by the short leg, and that gives me the longer leg. And notice relationship between this guy and this guy, the short leg and the hypotenuse. It's a 1 to 2 relationship. It's 1/2 as long. So that means this relationship over here must be 1 to 2, which means this guy must be 4 and this guy must be 8. So long and the short of it is, no pun intended, the hypotenuse is always twice as much as the short leg, and the long leg is root 3 times as much as the short leg. So the short leg is going to be our driver here. It's going to be driving the bus when we have this 30, 60, 90. Now, whenever I draw a 30, 60, 90 triangle, I try to do my best to make it look somewhat to scale. And all I need is to make sure that I have one leg significantly longer than the other leg. So even if I drew this thing lying on its back, I'd want to know that the short side here should have the 30 across from it, and the long side here should have the 60 across from it. And of course, the 90 has the hypotenuse across from it. So here's our formula. It's going to be side length, then side length times root 3, and then 2 times the side length. There's our formula. So the short leg, then we have the long leg, and then we have the hypotenuse. So when you have the short leg, this becomes a really easy exercise because everything's kind of given in terms of the short leg. So our longer leg, letter B here, would just be the short leg, which is 4, multiplied by root 3. And then our hypotenuse, being across from the right angle, is just twice as much as the short leg, which is 8. So there you go. If you are given the longer leg, this is the one that is probably the most challenging, because what we need to do is figure out what the short leg's going to be, because everything comes from the short leg. You're always, regardless of what you're given, if you're given the short leg, great, you want to start from there. If you're given the long leg, you want to work your way back to the short leg. And the trick there is divide by 3, divide the long leg by 3, then multiply by root 3. So if I want to find out what this x is here, I'm going to take my long leg, I'm going to divide it by 3, and then multiply by root 3. And that's 4 root 3. Notice 12 divided by 3 is 4. So x is 4 root 3. And then lastly, the hypotenuse. Once I have the short leg, again, remember when you have the short leg, the hypotenuse is just twice as much as the short leg. So as soon as I have this guy, all I have to do to get the hypotenuse, which is y, it's going to be twice as much as the short leg. So 2 times 4 root 3, which is 8 root 3. So I guess I should have put an x here for this guy. All right, so when you're given the long leg, divide it by root 3 and slap a root 3 on it to get the short leg, and then double that to get the hypotenuse. Now, when we have the hypotenuse like we do in this last example, what we need to do is get back to the short leg, and then once we have the short leg, we're going to slap a root 3 on it. So let's think. When we're given the hypotenuse, the short leg is half the hypotenuse. Okay, so the short leg, which is x, is 1/2 of the hypotenuse. So notice, I could put 5.5, but I'd rather just write 11/2. Okay, now for the y, the long leg, all we have to do is think about our original relationship. The long leg is the short leg times √3. So once you have this short leg as 11/2, all we have to do is jack a √3 on it, and that's going to be 11/2 √3. You can just leave your answers like that. Trust me, I don't want any decimal approximations of the square root of 3 or 11/2 √3. Just leave it in terms of radicals. That's the beauty of this stuff, is that we can get an exact value in terms of the square root of 3 to get our answer. So to wrap up this section, really, there's only 5 different problems that you can be given. You can be given a 45-45 situation, where you've got the 45 and a 90 here. And in a 45, remember that the two legs are going to be equal to each other. So if you're given one, you know what the other one is. So if you're given the leg in a 45, 90, let's say it's, 7, you know that the other leg is 7, and then you know the hypotenuse is 7 √2. So that's one problem type, when you were given the short leg first. If you were given the hypotenuse, I'll put this as example 2. If you're given the hypotenuse, I don't know, pick a nice odd number like 9. Then you work backwards to get the short leg. Divide it by 2 and slap a √2 on it. So you have 9/2 √2. Same thing over here, 9/2 √2. And that's it. Those are the only 2 kind of questions you can be given for the 45, 90, because there's only 2 different side lengths involved. Now, for the 30, 60, 90, we've got 3 problem types. We've got the first one where you have the short leg that's been given. I'd say this is probably the easiest. Let's say it's 3. Let's say it's, sure, I'll let it be 3. Then the long leg is 3 √3. Just slap a √3 on the short leg, and then the hypotenuse is double the short leg, which would be 6. The second type is if you're given the long leg. Let's say this guy is, 7. Then the way to get to the finish line is to divide the 7 by 3 and then slap a √3 on it. And then to get to the hypotenuse, we just need to double this one. So twice as much as 7/3 is 14/3 with a √3 on it. I'm using nice, ugly numbers to make sure that you're not worried when you come across a problem like this. And then lastly, in the 30, 60, 90, when you're given the hypotenuse, let's make it 10. Well, our mission is going to be go to the short leg, and again, the short leg would be the one across from the 30. So to get the short leg, I'm going to just divide it by 2 and get 5, and then I go over to the longer of the 2 legs and slap a √3 on it, so I get 5 √3. And that's it. That's the only types of problems you can be given. There's 2 different problems you can be given for the 45, 90, and there's 3 different problems you can be given with the 30, 60, 90. So that ought to do it, and you can get an assignment to practice up on this stuff. Good luck.